Now I'm pleased to introduce this morning's keynote speaker, John Lambert. John is the General Manager of Trustworthy Computing at Microsoft and manages the network security and science team in the Trustworthy Computing division. He is responsible for monitoring the security of Microsoft's network and the development of novel defenses protecting systems from attack. John founded the Microsoft Security Engineering Science Center team, which works on cutting-edge methods to detect vulnerabilities and exploit activities and neutralize them through advanced technological countermeasures. Previously at Microsoft, John managed the Microsoft Security Response Center's engineering team. Please welcome John Lambert.
Okay, good morning. All right. I'm really excited to be here. It's kind of a special moment for me. I came here about 5 years ago, and I met with Adam, and I met with Blake. How many of you know Blake Strom? Okay, so I met with him. He showed me this small project he was leading called ATT&CKcon. It was an inventory of techniques and things like that. I thought it was pretty interesting. If I would have told Blake then that 5 years later, there was going to be a conference, and over 1,000 people are going to tune in online, over 100 people are going to come to it, dozens of vendors are going to be implementing what this project is doing, he would have said, "You are crazy. There is no way that is going to happen. What are they smoking in Seattle? And is it legal? This is insane." And actually, if you do know Blake, he's a pretty low-key guy, so it probably would have said something more like, "Interesting." Part of the reason that I was at MITRE was I was going around visiting a number of organizations and just seeing what they were doing in network defense. What was working? What did they find? Because what I found is despite the doom and gloom of all the headlines, a breach every day, there were a set of defenders that were being very successful at defending their networks. And I wanted to understand what these defenders were doing, what they were finding. And as I found in talking to them, a lot of them basically, they took the received wisdom of the Infosec canon, and they took the stuff that worked and they kept it. The stuff that didn't work, they discarded it, and they invented stuff that they needed to replace things that really were effective. And I would say, while some of them had great tools, some of them had great resources and data, a common thing that they all had was a different mindset when they approached network defense. Some of the differences that I saw in the mindset of both the folks at MITRE and other organizations I went to was instead of thinking about defending a list of important things in their network, thank you, Nancy, things like domain controllers or certificate authorities or key repositories, defenders typically, especially at that time, really thought of their network as a list of important things to defend. And there was no shortage of things that told them how to go after important lists of important things. The reality is your network is a graph. Adversaries see that graph, natively operate in that graph, and the advanced defenders were using those concepts to both analyze their network for dependencies and then building safeguards and detections across them. Also, there was a difference between IR teams that would manage incidents. That was the thing that was really the heartbeat of their life. An incident today, an incident tomorrow. And the more advanced defenders recognize that they don't have incidents, they have adversaries. And they need those adversaries cause those incidents. That's where they have contact with them. But you can really learn a lot more about what you're facing by studying everything those adversaries are doing, even when they're not on your network. And they build these trusted networks and talk to others in the community to learn about what they're doing. And so these advanced defenders are really managing adversaries. The other thing is a lot of this world was a very secret world. To some degree, that is still there. But this incidents, attacks, threats, nobody really wanted to talk about this stuff, or maybe they only talked about them in classified spaces. God forbid they go to a conference and take their IR people who know about all the secrets of bad things that have happened to an organization, talk to other people, maybe even their competitors. That would be crazy. And yet other defenders realized that they face common threats, they face common adversaries, and they were willing to put their people forward to talk and build networks of trust and learn to communicate each other about very sensitive incidents, because the reality is this security community is one that is built on trust in people. And learning was really what these companies were wanting to do. They were optimizing to learn, not optimizing to keep things secret. They also had things like, instead of, if they did penetration testing or red teaming, they didn't view it like a report card. How did we do? Did we get an A? Did we pass? In that mode of thinking, red teaming or pen testing is kind of like, it's an output, you know. You do some testing, you get some results, it's an output. And these advanced defenders really viewed pen testing and the results that it got as an input into a continuous improvement of attack and defense and finding weaknesses in their own network. And they also had this mindset that they didn't think about stopping attacks. Oh, put two-factor auth in, now we stop that attack. Or put this other technology and now we've stopped that attack. Because that really is a mindset that doesn't think the adversary is going to co-evolve with you. And so these advanced defenders, they had this mindset of, they're not really stopping attacks, they're just increasing attacker requirements in order to progress the next kind of attack, and they were ready for those things. So I went and met with a number of these organizations to get these kind of insights that they were getting and identifying. And I would say at Microsoft, we hold an event called One Hunt. And One Hunt is an opportunity where, of course, we have a number of divisions at Microsoft. They all have red teams. They have blue teams. They have their specialties. They have their networks are each different. We have the Windows, Office 365, the cloud, et cetera. And One Hunt is an opportunity where we bring all of them together, members of every red team, members of every blue team, and we give them a common task, and then we tell them to go after it. And the purpose is really not what the red team is able to accomplish or what the blue team is able to accomplish. It's all about those team members working together and learning. And this one particular year, you can see here, we had red teams from over 7 different red teams at Microsoft. Yes, that is Mark Rasinovich on the red team photo. No, he was not on the red team. That would be cheating. See the blue team down here. And then we assembled these folks, give them an objective, and give them freedom of action. They can do network attack, they can phish employees if they want, they can tailgate into the building if they want and try to get access to accomplish their objectives. Some insights that we would get out of this event. I talked about that graph-based thinking. Well, this was an opportunity for defenders from all over the company to really practice graph-based thinking and try to have that situational awareness of what was the red team doing at any moment in time, how was that activity linked together, and then to go from this, and then later after the event is over, see what the red team had really accomplished at that point, and sort of reveal cards and see what they knew versus what was really going on. Some of our engineering teams, they're embedded in this event. So not just the operational defenders, but the engineering teams, and they watch how do defenders really do things. And one of the insights that they got was when some activity happens, an alert or some suspicious thing, they saw defenders are constantly going, how did this attack come to happen on the machine? What started that net.exe process, for example? How did it come to get activated on that machine? And that sort of process hierarchy now got embedded into things as a result of just that insight that came from engineers sitting down, seeing how network defenders did their work, and so on. And then one of the techniques the red team did is they knew some of their techniques might eventually get discovered and remediated. So one of them was able to successfully tailgate into a building, and they brought a Raspberry Pi based device. And they found, that neglected part of any building, which is the copy room. And they went into the copy room and then they plugged it in. And this would give them access, a network beacon that they could do their attack, even if some of their other malware was found out. How long do you think these devices lived in that copy room? Still there. So that would have been my guess. How many people think 30 days or more? Yep. How many think, anybody optimist here? 5 days or? All right, one optimist in the back. Actually, they planted 2 devices, and they were both found and reported by everyday Microsoft employees within 48 hours. I personally was blown away. I agree. I thought they would still be there. And it was just everyday employees that actually had no idea an event was going on, and they just went into the copy room and they said, what is that? That shouldn't be here. And they had a way to report it. We had alerted the physical security folks at Microsoft so they would not call the bomb squad and detonate these devices. So they knew what to do, when to respond. But this is sort of some of the principles designed into this event. You know, like I mentioned, reveal cards. So this is, a lot of red teams want to keep some of their things secret, their methods from the blue team, because they don't want the blue team putting a trivial detection in to find their activity. And this is a full scope of revealing. What did blue team know? What did red team know? Part of the reason, one of the things we found out of it is the people that team together, that sit there and co-work these events, when there's actually a crisis, they work better together in that crisis because they already know what your strengths are, what you can do for me, what data you have access to, what analysis you can do, and that was really important thing. Another sort of principle is this is any kind of red team, blue team event is going to have a thing where, they got here, you didn't find out. But really the focus of this event is sharing learnings, not about shaming. So there's no scoring, there's no ranking, there's not points accumulation or anything like that, because it's not about creating winners and losers. It's just about creating that learning environment for people to learn, teach, collaborate. We would have folks that would come up before the event, they would give classes on volatility or some other kind of tool or whatnot. And we're always kind of striving to bring new findings and new techniques. So one of the things that occurred to me as we put this event on year over year is we'd have new blue teams and new red teams that would come on board, maybe an acquisition, or those red team or blue team members would have new team members. And Infosec is very much an experience-driven profession. Like, you gotta do it in order to learn how to do it. It's kind of a school of hard knocks type thing. And so how do you go and increase the rate of learning where people can get up to speed faster? Teams that are starting this out that haven't maybe been through big incidents to work through that are those formative things, how do you increase the rate of learning and proficiency for them? And some of that is what I want to talk to you about today. There's this quote here that I found that I really liked, which if you want to go fast, go alone, but if you want to go far, go together. And I think it's an important thing that it really goes to the heart of why community is very important. I actually think both of these are important in Infosec. We need researchers that are on the cutting edge, that are developing advanced things, that are learning, researching both for attack and defense. But if we want to improve the overall community's ability to be successful on these problems, we need to really work together in a way that helps teams get better faster than their current rate. So I want to talk to you today about 4 areas that I think can really help improve information security and help accelerate learning in it. So one is promoting community. Another is organizing knowledge. The next I call executable know-how. And the last is repeatable analysis. Let me start with promoting community. So community has always been an essential part of Infosec. This is a photo of the back of my office door. I talk a lot at various things, especially at Microsoft. And earlier this month, I was in Montreal at Virus Bulletin. The day before that, I was at Sector, which is the largest gathering of IT security professionals in Canada. And part of the reason I do it is I learn by communicating. When you have to write down what you're doing, why you're doing it, it really forces you to pop out a level and think about, what the heck am I doing? What are we trying to achieve? What are the proof points of progress and whatnot? And so I find that for me, communicating is just a way that I learn better. And conferences are a great way to do it. And this profession is definitely one where it is built on a lot of relationships. I'm curious for people in the audience, how many of you know somebody in the audience that you knew from a prior role, not from the current role that you're working in? How many know from a prior role? Just raise of hands. I mean, there's something about security that just gets in people's blood and they stick with it and they just pursue a career in it and different things. And I think that those durable relationships are really a key part of this, and conferences are definitely a way to do that. Blogs are another way that people contribute. Casey, aka Sub-T, every time Casey blogs about something, I guarantee you people at Microsoft are writing that down and doing something about it. I'm sure many of you are here doing as well. Another blog, Enigma, a lot of amazing techniques that come out of this blog that we spend time analyzing, understanding, sharing, researching, and so forth. Twitter, as many of you know, I'm very active on Twitter. I find it, actually, if you're a lazy person, Twitter is a fantastic way to meet people. Conferences, you have to travel. Like, I came here from Seattle, plane delayed 5 hours due to fog, finally got here. Twitter, takes 5 or 10 minutes to go put out something and make a connection with somebody. Nick is at Fire. I don't know if Nick is here in the conference. If you all raise your hand. Okay, Nick. So Nick and I have a little bit of a battle going on. So Nick is always tweeting about his comm scriptlets that he finds on VirusTotal. And we're always racing each other to find the comm scriptlet first and whatnot. But what Nick and I have really going on is not a comm scriptlet battle. It's an emoji battle. And the battle is who can use the greatest number of emojis and still be taken seriously. So you can see one of mine here. I went a little over the top on this one. And then I would say I think I do have a little bit of edge because I did post a tweet of how you, in Windows 10, can change the name of your computer to an emoji. And I did, and it works. It's unbelievable. So much so that we're on this battle that we got accused of ruining Infosec. So there's a hashtag ruining Infosec club. Actually, they kind of called out Patrick Wardle, does a lot of Mac research, and myself, and I was like, hey, don't forget about Nick Carr from FireEye, Mr. Emoji, where I learned my emoji skills from. So anyway, hashtag ruining Infosec club. And then, of course, you can participate in the community by creating shared tools. Mimikat's one of my favorites. Benjamin Delphi, the author of it, super nice guy. The thing that is amazing about Mimikatz, besides the fact that red teams everywhere love it, is it's one of these tools that takes you 5 minutes to understand what the heck this tool is doing, but it takes you years to actually do something about what the tool means in your network. The notion of lateral movement, the dependencies on how things are connected at the credential layer. You will spend years as a defender working on credential isolation, network segmentation, just-in-time admin, all kinds of things to reduce the scope and impact, the blast radius if a credential is exposed. And it's one of the phenomenal things about Benjamin's tool. And the last area for community I think is important and we could do better on is mentoring, which is how do you get people to grow faster in this profession? You can mentor at the individual level. You can mentor at the team level, even with inside your own organization. At Microsoft, we have this thing called reverse mentoring. It's a tool where it's not the expert teaching the student. It's a reverse, where somebody that knows and experiences something that they want to teach the rest of the company about. You think of it, we use it a lot in a diversity context, which is instead of having senior managers talk to people about how diversity and inclusion are important, we have people that live it every single day teach those senior managers what the heck this stuff is all about and what it's like to really live and experience it. And of course, organizations buddying up with other organizations, and then industries that maybe have encountered some of these, come into close contact with cyber and other things, or some of these advanced adversaries, buddy up with other industries. I found that there's always some unique research, and you'll see later in this talk, there's these other adjacent areas like the data science community, machine learning community that have very innovative tools and techniques that are starting to make their way into the world of network defense. And crossing those corridors, I think, is very interesting and very important. Okay, next, organized knowledge. So clearly attack fits into the world of organized knowledge. If you want to teach people something quickly, you need a way to efficiently digest it, organize it, have a taxonomy, make it easy for people to learn the net new things they have to do. I think 5 years ago, this matrix was a lot more sparse than it is today, but I also think that's a reflection of researchers contributing new ideas, getting these ideas that maybe were only known about in secret IR, spaces, or maybe only in classified environments, and eventually those things became just added to common knowledge. I see Chris over from FireEye. I know it worked a lot of IR, saw a lot of techniques that have eventually made it into this space here today. And so I'm really glad to see, and I think it's a great proof point of just how much the community has embraced this project by MITRE, the ATT&CK project, to contribute to this, because I think the contributions are very important. And then, of course, having detailed description about what the attacks mean, very important. At Microsoft, we track threat groups. Everybody in this industry has a way they refer to threat groups. We assign them an element from the periodic table. So, for example, we have Strontium. FireEye calls them APT28. CrowdStrike calls them Fancy Bear. We assign an element once we track and understand these threat groups and whatnot. And what would be interesting, I think, is imagine each one of these threat groups was described in terms of the techniques that they were known to use in the MITRE attack matrix. And actually, if you go to this attack navigator, I don't know who created this thing here, if they're there, but there's a super useful tool that's on GitHub where it's got the matrix loaded in it, and then you can do things like select your friendly APT group, that threat group that you're worried about, and then it will highlight the various techniques that they come from. I don't know exactly where the data, the mapping came from, but it would be interesting, and I think a level of collaboration that the industry could publish all of the MITRE attack mappings for their threat groups. Maybe some of the data of that threat group is secret, or their business is selling those indicators or detections. But I think this higher level description of look, this is the set of techniques we've known them do would be very, very useful to defenders everywhere. And part of the reason for that is what I've seen is a lot of organizations that are looking to assess their defenses or purchase security products. What they don't really want to know, do you do a great job? Do you get 100% A+ on the entire matrix? What they care about is, look, we face very specific adversaries. How well do you do on them? Now imagine people that track threat groups published their mappings of them. Then, Joe Company could take all of those mappings for all the threat groups they worry about, do the intersection of them and say, now how do these products I'm evaluating, endpoint products, network products, what have you, do against that part of the matrix that I have the greatest amount of concern about. And I do think it's something that in the industry we could come together, publish these things, have some style, have some way where we can make these things available across all the companies. So executable know-how. So having knowledge is great, but then we need to speed ways to render that so that people are gaining value and action from that. Without having to just do okay, now I understand this, now I have to swivel chair over and do something with that. This was an alert put out by US CERT on some cyber activity. It had actually a ton of technical content in it. They had scripts that the attacker was running, a lot of useful information in here. And yes, as a defender, you could say, now how do I go from this, what the attacker is doing here to how does my system know how to find that activity? These were examples we came up with where it's like, oh, you could construct a query that looks like this or it looks like that, and every defender or organization or product vendor could come up with how to do that. There is a project called Sigma, which if you hadn't heard of it, I wanted to put it out there as just an example of, if you know about Yara, how many of you know Yara? Imagine a lot of you do, right? Yara is great for scanning files. Snort, great for scanning packets. And Sigma is really aimed at matching against event data. And so it's an open source project. Florian is the lead on it. And it's basically, you have a format that you can describe matching event data. Think a Windows event, a network event, a firewall event, in a sort of a generic language. And then it has ways to translate that to very specific product backends that actual practical defenders need it to work in that way. So you can go on GitHub, find all these things. These are the different categories of where Florian and other contributors have already created alerts and rules, detections. If you click into just Windows, you can see there are rules for Sysmon, the sysinternals tool, PowerShell, other ones that are built into it. Many different rules. This is just one directory. You can see them. And this is an example of a rule in this project. It has ways to, in a generic language, to specify this is looking for the sticky keys attack. If any of you know about this accessibility type of attack. And it's a way to say, look, when you see these fields and these other things together, that means you have evidence that this attack is happening to you. And it's just a generic way to do it. And then the nifty thing about this tool, this project is, well, you don't use Sigma itself. What you're using is Splunk or using some other product or ArcSight or whatnot, and you need that detection to show up in a way that tool can understand. And it has a bunch of back-end translators, again, all open source, to know how to translate that generic language into all these other different back-ends. And so now you start to see what the power of community would be. Imagine the community came together, wrote those kind of rules, helped advance the language itself, and then these back-end translators would work across all these different vendors. Now, any new team starting out is going to have the power of all these awesome detections that work great across all these different backends that they may be using. And I know many companies, they don't just use one of these tools. They may have Elasticsearch or Kibana on some part of their network. Another team may have Splunk or some other, commercial off-the-shelf product or whatnot. But I like this project both because of the community aspects. It's on GitHub. You can submit a pull request. You can contribute new rules. And yet there's ways to translate it that make sense for a lot of different backends in a vendor-neutral way. This is an example of what a translation may look like. But the notion of going from a high-level description of a generic thing to something you can take, run, get results on is I think, important. And then another project that Florian has is just a signature of Yara rules. Of course, many of you know Yara, and he has a number of different rules that he's contributed into his repository. One of the nice things about his repository is if you contribute a rule into it, it's run against all the submissions on VirusTotal. And so any hits from that rule are automatically annotated in the community tab. And so if you have a rule and you want it, wouldn't it be neat if the rule you wrote was run over everything in VirusTotal? Maybe you have a VirusTotal account where you can put those things in, get hits and whatnot, but you also don't mind it being contributed back to the community itself. Well, this is just an example. I created a rule for a particular CVE, and I contributed it to his project. And when you do that, this is how the detection shows up in VirusTotal that any VirusTotal customer can see. Actually, you can see this publicly. You don't have to have a paid subscription to VirusTotal. You have this annotation here that says, hey, this particular rule hit. If you wonder, why did that detection hit? What was it looking for? You can go back to GitHub, see what the basis of that was. How did I make that rule show up in VT for that? I just submitted a pull request to GitHub. I came up with my Yara rule, tested it, seemed reasonable. I went to the public GitHub like any of us could do. I submitted a pull request. I said, hey, what do you think about this rule? I didn't actually even know Florian, and I have not ever met Florian. I only know Florian through Twitter, like many people these days. But, and you notice, if you just look here, not only that, but just contributing in this way, Florian's like, hey, look, you can optimize your Yara rule by doing this or by doing that and improving that. And I've learned a lot of different tricks of the trade just by participating in a community like this. And so as a result, just by participating in the community, these hits now show up, and they show up for everybody. So there's a lot of different experts in the Infosec community. Imagine those experts had areas that they sort of watched over attacks in that space. Maybe COM scriptlets, and they contributed those rules that seem to find all those new scriptlets every single day to an open source repository. Now every defender benefits from those things. Okay, testing and validation. So a lot of that was about writing rules that detect stuff. There's also, how do you know your rules are firing on the right stuff? There are a number of people that have done research on how to use MITRE ATT&CK in order to assess how your defenses are. Pick the techniques you need to care about, and then measure and score yourself. The Atomic Red Team is a project. I think they're talking later today or tomorrow at this conference about how to generate test cases that actually allow you, synthetic, that allow you to test whether your defenses are firing. Because detections are great, but if you don't know how well they actually, what their signal is, what their true positive, false negative, false positive rate is, you don't know how great your detections are. So even contributing to just things that do test case generation, I think, is a very interesting way to participate as well. Okay, repeatable analysis. So this is a section where I'll talk about a tool called Jupyter. How many of you have ever heard of a tool called Jupyter out there? Okay, excellent. So Jupyter it's an open source tool. It comes out of the data science, machine learning community. It doesn't come out of the Infosec community at all. Actually, what I find is a lot of people coming out of college these days know Jupyter. A lot of established Infosec professionals, engineers working on security at Microsoft may have never heard of Jupyter. And it's sort of one of those things that, if you've never seen it, you don't know what these kind of tools can do in the world of Infosec. But it's got a vibrant ecosystem, advanced by people every single day. Even when we're not paying attention or sleeping, there are people advancing this technology to make it better. It's got a yearly conference. There's already 2.6 million Jupyter notebooks that are hosted on GitHub. Every cloud supports this technology. You don't need to run it in a cloud. You can just run it locally. You can run it on-prem, but you can run it on the cloud. And the key thing about this is there's kind of a picture of what the Jupyter notebook looks like. And the way to think of it is, it's like, if I were to explain this to somebody at Microsoft, it would be, imagine you had OneNote and you had an interactive Python interpreter built into it, where you could have a cell that you say, go get me some data, and then you can manipulate it and the output of that and refine it and call any API you want. Anything the Python universe can do, you can do. You can visualize right in line with the notebook. And then once you're done with that, you can share that notebook with others. And then when that other person takes that notebook, not only do they see what you did, they can actually just interactively rerun it themselves and tweak it. And so I think this is a really profound teaching tool, which is why a lot of folks in university use this tool. You know, it's one thing to say, hey, I analyzed that malware, or I did this research on these logs, and here's my conclusion. And then how would you share that? You might have to like write an email and explain everything you did. Here you can do it all in the notebook, fetch the data, refine the data, slice and dice the data, and then visualize the data. And then when you capture that one, that's your entire analysis. They can see, why did you get to that conclusion? They can understand your whole chain of reasoning there. And then others, more importantly, can repeat it. They can start with what you did. They don't have to secretly learn your know-how. They can just go there and hit run on each cell and repeat it, and then do derivative work from it. So that's kind of what Jupyter is in a nutshell. These are some different ways that I've seen Jupyter used. This is just an example of take a query, and then you want to visualize it. So this is a set of machines and what net blocks they're talking to, visualized in what's called a chord diagram. The product where I got this data from, it didn't have support for a chord diagram. It's just like, one of these visualizations that's out there. Products normally have bar charts and pie charts and all those kind of things, and a chord diagram was just one it doesn't support. But of course, because of the diversity of the Python ecosystem, somebody's already written not only this, but lots of other amazing visualizations out there. And through this power of connecting your data to open source, you don't have to wait for some vendor to come up with support for this. You just have a way to get at your data this easily, visualize it, and come up with some insight, interact with it. And then how do you have the person next to you that doesn't know how to do this, repeat this? All they have to do is take that notebook and run it. So this is rendering as a chord. This is another sort of different visualization, a scatter plot, which is these machines, what net blocks are they communicating to? Clearly this net block is communicated to by many machines, and the whole point of this is, I want to find an outlier. I want to find odd things to chase. What is this one net block that only one of these machines is communicating to? Imagine taking all your domain controllers or all machines of a similar kind and plotting them like this, and then saying, why is this one special? Why is this one doing something different? And it's just an example of something that's easy to do by connecting with the power of sort of the Python and open source ecosystem with all the visualizations that are there. And you're not limited by whatever the heck your product may or may not be to do, your tools may not be able to do. This is just another example of fetching some data from alerts, getting hashes from malware detections in those alerts, and then calling the VirusTotal API and see what does VirusTotal know about these things. So you can start to see how you could script these things together for the basis of automation. And then, truth be told, I didn't discover Jupyter by researching on a website. I went and visited Lockheed Martin many years ago, and I met a guy named Eric Hutchins. I don't know how many of you know Eric. Eric is a giant in this field, and he exposed to me to their use of Jupyter. And this is a notebook that Eric has published on GitHub that is how to, he's using volatility here to do some analysis. It's got this markup in here so you can explain what he's doing and then actually do it. And Eric was really, the teacher that exposed me to this stuff many years ago. Like I said, when I talked about those defenders out there with these practices that, being successful defending their networks, this is 5 years ago, Eric is teaching this to me. How many of you are hearing about this for the first time? And so, again, this is part of the power of community, which is let's take these tools and technologies, come together, have a way to showcase them, make them out there. This is another one of just I want to cluster things together. All of these things are possible just through using, standing on the shoulders of giants and so forth. So, and then I mentioned there's this Jupyter conference. At this Jupyter conference, which is not a cybersecurity conference at all, it's mostly data nerds and machine learning people and data scientists and whatnot. So at this conference, Netflix showed up. Netflix has tons of data. I mean, their most important thing is to recommend that next movie for you to watch. And they do an amazing amount of machine learning and all that to do it. They have really embraced Jupyter Notebooks in a major way in two important aspects. One is they found they have all these different roles and personas at their company, not just the data scientists, but business analysts, data analysts, engineers. And the notebook is kind of a tool they can all use, and it sort of makes sense to everybody. Like, you don't have to maybe be the one to create it, but you can be the one to use it. You can be the one to take some work somebody did and then tweak it for a different data set or whatnot. So they found it to be a very versatile tool, a lot of roles. And I think in Infosec, we have all of these different roles as well. And so I think the fact that it has this versatility that they're finding in Netflix is an interesting thing that could be used in other fields as well. And so notebooks, I've kind of presented it as one tool you can do to do repeatable analysis. You know, you do your analysis in it and you get your conclusion or whatever and you're done. Now, there's another project they have, which is, let's say you want to do that every day. Or hey, when that alert fires and you did that investigation, you want to do that every time that alert fires. Or you want to run a job every single day. So there's another project they have called Paper Mill, which is about making those notebooks executables, where there's a headless system that takes those notebooks, you save them, and then it will run those notebooks for you in an automation. And what I think this is interesting for a SOC is because if you can have SOC analysts that can master notebooks, learn a little bit of Python, feel comfortable with that, modality of doing their work, now that same way they did their analysis is the way that they can automate their work. And they can tie that to orchestration or tie that to things that remediate things. And now the tool that is their analysis tool is also their automation tool. And suddenly they start to get in charge of their own productivity in a way that's not like before, where they have to swivel chair over to some engineering org or IT operations group and say, hey, I found this bad thing on the network. Can you automate this away so we don't see that alert anymore, please? Please. Now they have the ability to basically automate all this kind of stuff themselves. So interesting things. And like I said, there's a whole community behind this stuff. Those notebooks have, spending time in Python, you have to have all your libraries right that maybe have those VirusTotal APIs or whatever that you're using. And you're not a programmer type person. You're not somebody who's going to be able to get all of, install this SDK and get everything going. So they have this other open source project called Binder. And what Binder is all you have to do is if you create a URL, to a notebook hosted on GitHub. I send you the URL, you click the button, this service will spin up a virtual machine, load up all the Python dependencies that the author of that notebook has said are required, and then you immediately in your web browser have a notebook that you can run and interact with and start to execute, and you've had to install nothing in order to get there. And so organizations can take this Binder stuff and then host it themselves and make it that easy to share notebooks. So all of these different facets sort of come together in this term, what I call the GitHubification of Infosec, and it's a bit of a mouthful, but the idea behind this is imagine the community came together and described all the threats and threat groups in terms of the attack matrix that they are known to exercise. And of course, today we have the enterprise matrix, but imagine a cloud matrix, an IoT matrix, an ICS matrix, and these threat groups get described in terms of this. You'll never get us security threat intel folks to ever agree on having one name for a threat group. Just ain't going to happen. I know everybody's asking for it. Ain't going to happen. Will we have a Rosetta Stone? I don't even think we'll really do that, even though we may privately have that. But what I think what you could see as a common denominator is all of the threat groups described in terms of the attack matrix that they find in common, and then combine that with, of course, a technique database like MITRE ATT&CK, and then how do you translate those techniques and tactics down to detections? You add in a project like Sigma that has a way to translate from a technique, describe it in a vendor-neutral, open-source, generic, community-friendly way, and then now you have a way to translate that down to specific detections that work in all the detection products that network defenders use every single day. And then the analysis that's done that those products help them and those tools help them do are saved in reusable, rerunnable, schedulable notebooks, all of this open source. And I think it's something like this. I'm not necessarily saying each one of these things is the right answer. There are other projects out there. There's other things besides Sigma and so forth. But the point is, I think it's important for the community to come together, come up with vendor-neutral approaches where experts can contribute their ideas, their techniques, have a way that those work and tick and tie together so that you can go from knowledge down to execution, down to data, down to repeatable analysis, so that a new, with hope, an Infosec practitioner entering the field 2 years or 5 years from now is going to start with a lot more know-how and ability to actually have prowess on this problem that they don't have to spend 5 years learning through IRs in order to be proficient with it. And when knowledge is shared about, think that Russian threat group that I mentioned the CERT bulletin on earlier. Imagine all of that knowledge was captured in a way that was just instantly usable, repeatable, and so forth. I kind of hope the Infosec practitioners of the future will be able to stand on top of all that technology and community that's behind it. So I hope you found this interesting. I wanted to come here and talk about really how do we use community coming together with these areas of common interest and use them to accelerate learning for everybody that is in this field today through promoting community, of which this conference is a super important part of that, through organizing knowledge, through making know-how executable, and through making analysis, that expertise, repeatable in ways that if you're a new person, you can start with the analysis that an expert did, and you can play with it, and you can learn, and you can iterate from it. And then I'll just close with going back to this quote I put earlier, which is, if you want to fast, go alone. If you want to go far, go together. And I think community is a great way to go together. So with that, thank you for your time today.